Let me start with a familiar tragedy. You open an AI tool. You explain the project, you give it the folder, you give it the goal, you give it the constraints. It gives you a good answer. You feel powerful. Then tomorrow you open a fresh chat, and suddenly your advanced AI assistant has the memory of a hotel receptionist on their first day. Pleasant, confident, and completely unaware that you already checked in. That is not because the model is bad. A great model inside a weak workflow is like a sports car in a parking lot. Very impressive engine, very little forward motion. Most people are not failing with AI because they need one more prompt trick. They are failing because their AI setup has no operating layers. The knowledge is in one chat, the tasks are in another app, the files are somewhere in a folder. The decisions are buried in a transcript. The tools are connected sometimes manually, with the emotional stability of browser tab roulette.
So this is not another best AI tools video?
No, this is the opposite of a tool haul. We are not collecting shiny apps like fridge magnets. In this video, we are going to build the idea of a hybrid AI operating system, a model-agnostic structure where different AI models, coding agents, chat assistants, local tools, databases, and task systems can work from the same durable context. The goal is simple. If you switch from one AI environment to another, your work should not collapse like a badly labeled folder named Final, Real Final. By the end, you should understand the building blocks, the knowledge layer, the task spine, the domain map, the MCP and tool layer, the context handoff system, the proof dashboard, and the governance rules that stop your agent from becoming a very fast mess generator. The current AIOS project is my reference example, but this is not a private repo tool. Think of it as a blueprint. You can build your own version with your own tools, your own files, and your own tolerance for chaos. So what is a hybrid AI operating system? It is not one chatbot, it is not one model, it is not a magical folder where productivity goes to become a PDF. A hybrid AI operating system is the coordination layer around AI. It decides what the AI should know, where work is tracked, which tools it can use, how context is carried forward, what evidence is preserved, and where the human review gate sits. The model is the engine. The operating system is the vehicle, the road rules, the dashboard, the fuel gauge, the brakes, and the part that politely says, maybe do not deploy this to production at 2:13 a.m. because the vibes feel correct.
Why call it hybrid?
Because the future is not one model doing everything. The useful system is hybrid across models, hybrid across tools, hybrid across local files and cloud apps, and hybrid across human judgment and automated execution. One day you may want a chat assistant for thinking. Another day you may want Codex to work inside a repository. Another day you may want Claude Code, co-work style environments, anti-gravity, or another agentic tool to operate through editor, terminal, browser, or a managed workflow surface. If each environment has to be trained from scratch every time, you do not have an operating system. You have a talented group of freelancers who never read the project brief. The core idea is to move important memory outside the model. Your instructions, skills, task descriptions, domain structure, workflow rules, proof logs, and decision records should live in durable places: files, workbooks, task systems, databases, and manifests. Then any capable AI environment can be pointed at that structure and say, here is the project, here is the current state. Here is the next action. Here is what not to touch. Here is how we verify the work. That is the difference between asking AI to be smart and giving AI a system in which smart work can repeat. The most important design principle is model agnosticism. That means the system should not be built around the personality of one model, one vendor, or one chat interface. Models change, tool names change, pricing changes, features appear, disappear, move behind buttons, and occasionally get renamed by someone who has clearly never searched their own documentation. So the stable part of the system should be yours. At the top, you have human intent. The outcome you want, the standards you care about, the decisions only you can make. Below that, you have the AIOS control plane. Instructions, skills, task definitions, domain maps, artifact manifests, review gates, and evidence rules. Then come the model engines: GPT, Claude, Gemini, local models, coding agents, specialized agents, or whatever the next wave brings. Below the models, you have action layers, files, apps, APIs, databases, renderers, browsers, calendars, task managers, and local tools. At the bottom, you have evidence: what changed, what was checked, what is pending, what is blocked, and what should be opened next time. This is why model agnostic does not mean models do not matter. They matter a lot. A better model can reason better, code better, summarize better, and catch more edge cases. But the operating layer makes the work portable. If one model is the brain for today, the AIOS is the notebook, tool belt, procedure manual, task board, audit trail, and memory palace. Without it, even a brilliant model can spend half the session asking, "Wait, what are we doing again?" And to be fair, that question is also how many human meetings begin, so let us not judge the machines too harshly. The first layer is the knowledge layer. This is where most AI workflows quietly fail. People assume the chat is the knowledge base. It is not. The chat is a working conversation, useful but temporary. If all your project logic lives in chat history, your system depends on perfect memory, perfect search, and the belief that future you will enjoy archaeology. The knowledge layer should answer 6 questions. First, what is this project? Not the motivational version, the practical version. What does it do? Where are the files? What are the important folders? Which surfaces are authoritative? Second, how should agents behave here? This is where instruction files matter. In one environment, that may be agents.md, in another, claude.md, in another, a project memory file, a skill, or a system prompt. The naming changes, but the purpose is the same: durable operating rules. Third, what reusable procedures exist? These are skills. A skill is not just a prompt. It is a repeatable way to do a job. How to start, what to inspect, what to avoid, what artifacts to create, what validation to run, and what counts as done. Fourth, what is the current state? The AI should know whether a video is in direction planning, script review, asset lock, storyboard, voiceover, render, upload, or publish. If it does not know the gate, it may confidently start doing the wrong phase. Confidence is nice. Unauthorized progress is just chaos wearing a blazer. Fifth, what are the source of truth files? A workbook, manifest, package record, log file, task description, or database table can be more reliable than yesterday's chat summary. Sixth, what examples show the standard? The best way to get consistent AI output is to give it durable examples of what good looks like. So the knowledge layer is basically memory? Memory is part of it, but not the whole thing. Memory says, remember this. A knowledge layer says, here is the structure of reality for this project, here is how you are allowed to work inside it, and here is how you prove the work was done. That last part matters. A real knowledge layer does not just make the AI sound informed, it makes the AI easier to supervise. Let us make the knowledge layer more concrete. A prompt is a request. A skill is a procedure. If I say, make this video better, that is a prompt. It may work once. It may also produce a motivational TED Talk wearing a spreadsheet costume. If I define a skill for AI&U video production, it can say, open the workbook, identify the current RAW, check the manifest, inspect the package gate, preserve protected assets, update only the allowed files, validate the workbook, and stop before upload unless approval exists. That is a procedure. The same idea applies to research, script writing, animation planning, task creation, asset intake, voiceover, or dashboard maintenance. Each skill reduces repeated explanation. More importantly, each skill reduces repeated mistakes. But skills need authority rules. The agent must know which source wins when two things disagree. For example, if a chat summary says the video is ready for production, but the package manifest says script is still under review, the manifest wins. If a workbook says a proof asset is locked, but the folder has no lock file, the system should not pretend everything is fine. It should surface the mismatch. That is why source of truth files matter. They are the anchors that stop a workflow from drifting. In the AI/OS pattern, a good source of truth file is readable by humans and usable by agents. A manifest can list package status, locked assets, allowed next actions, and blocked lanes. A workbook can summarize state, artifacts, timing, proof assets, and review notes. A task description can carry a bootable next session brief. Together, these files create a shared operating surface. The human can review it, the AI can work from it. A different AI environment can pick it up later. This is the first major shift. Stop trying to make every chat remember everything. Put the durable knowledge where every session can reload it. The second layer is the work spine. Knowledge tells the system what matters. The work spine tells it what to do next. For many people, the work spine can start with the task manager. In this system, Google Tasks is useful because it is simple, visible, and can be connected through an API. The task is not just a reminder, it becomes a bootable work capsule. A weak task says, continue video. That is not a task. That is a note from someone who has already betrayed future you. A strong task says, AI&U video 4. Current gate. Voiceover script final candidate. Open these files. Do not render audio. Do not change locked proof assets. First action, revise scene timing and update workbook. Acceptance checks. Script file exists. Timing sheet updated. Manifest updated. Workbook validates. Now, a fresh AI session can start with enough context to move safely.
Why add domains or a live graph? Is a task list not enough?
A task list tells you what is pending. A domain map tells you where the work belongs. Domains are the larger areas of your life or work, a YouTube channel, an AI infrastructure project, client delivery, personal operations, research, content production, or visual production. A live graph is a way to organize those domains, so tasks, knowledge, and priorities do not float around like socks in a dryer. When a task belongs to a domain, the AI can understand context faster. A video task under AI&U has different standards than a client delivery task. A personal finance task has different privacy rules than a public content task. A research task has different evidence expectations than a render task. This also helps continuity. If every task carries the project tag, domain, current gate, files to open, first action, avoid list, and acceptance checks, you can stop treating context switching like a minor natural disaster. The work spine is not there to make your life more bureaucratic. It is there so your AI does not need a 20-minute bedtime story before doing useful work. The third layer is the tool layer. This is where the AI stops only talking and starts doing. Reading files, updating tasks, querying databases, opening apps, generating diagrams, testing pages, rendering previews, or calling business systems. The important word is governed. Tools are powerful, but an unguided tool layer is not automation. It is a toddler with admin access. Adorable in theory, expensive in practice. That is where protocols like MCP become useful. MCP, the Model Context Protocol, gives AI applications a standardized way to connect with external systems. Data sources, tools, prompts, workflows, local files, databases, and services. In simple terms, it gives agents a common plug shape. But the plug is not enough. You still need rules. A tool layer should define what each tool is for, what inputs are allowed, what outputs should be recorded, when user approval is required, what data is sensitive, and what evidence must come back. For example, an AI/OS tool layer might include a Google Task connector, a live graph or domain tool, a database query tool, a file inspection tool, a diagram tool, a browser testing tool, and a rendering tool.
If the tool can do the work, why not let it run freely?
Because speed multiplies both competence and mistakes. The system should allow low-risk reads easily. It should require stronger gates for writes. It should be especially strict around secrets, private data, client data, spending money, publishing, deleting, deploying, or sending messages as you. In the AI/OS pattern, the tool layer has 3 jobs. First, expose capability. The AI can reach useful systems. Second, preserve boundaries. The AI knows what it cannot touch. Third, return evidence. The AI does not just say, done, it shows what changed, what was checked, and what still needs review. This turns tools from random superpowers into an operating layer. The agent can act, but the system remains inspectable. Now we reach the part that quietly determines whether the system survives real work. Context continuity. AI conversations have context limits. Even when those limits are large, they are still limits, and long chats can become messy. The assistant remembers some things, compresses other things, and occasionally treats an old plan like it was carved into a mountain, so the operating system needs a handoff pattern. The simplest version is a fresh session prompt, not a giant essay. A precise boot prompt. It should include the project name, package root, current gate, files to open first, protected baselines, approved assets, blocked actions, first action, and validation checklist. In a single folder production package, this becomes very powerful. You can say, open the manifest, production readiness file, script candidate, timing sheet, storyboard plan, and dashboard. Continue from the current gate. Do not render audio. Do not publish, update only the script and state files unless approved. So the handoff prompt is like a save point? Exactly. It is a save point, but less dramatic than a video game checkpoint, and usually with fewer glowing crystals. The point is not to put every detail into the prompt. The point is to tell the next session where the details live. Context windows are not filing cabinets. They are workbenches. You bring the right tools and documents onto the bench for the current job. When the job changes, you cleanly hand off the state so the next bench can restart without confusion. This is also why manifests, dashboards, and evidence logs matter. They make context portable. If the work can be resumed from a short prompt plus a known folder, you can switch chats, models, or agent environments without rebuilding the world every morning. This is where the hybrid idea becomes practical. Different agent environments have different strengths. Codex can operate inside a repository, inspect files, edit code, run checks, use approvals, work with screenshots, and connect through MCP. It is strong when the work is file-based, technical, and needs verification. Claude Code has its own memory and instruction patterns, including project instruction files and auto memory. It is strong for long-running coding and agentic workflows when the project context is organized well. Co-work style environments, IDE assistants, browser agents, and emerging platforms like Anti-Gravity are moving toward task-oriented agent work across editor, terminal, browser, and workspace surfaces. The names will change. The principle should not. Your AI/OS should make the work reusable across them. That means the file structure, instruction layer, skills, task descriptions, manifests, asset registers, and review gates should be understandable outside one provider's interface. If Codex opens the package, it should know what the current gate is. If Claude Code opens the package, it should know the same thing. If a future agent opens the package, it should not need a personal introduction, a motivational speech, and a family tree. This is also why the system should be generic. Do not build your whole workflow around one tool's temporary UI. Use real-world logos and screenshots in the video to explain quickly, but build the operating concept underneath them. The best hybrid AI/OS is not loyal to a button. It is loyal to the workflow. Now let us walk through the proof layer. For the video, the proof snippets should be redacted and viewer safe. The goal is not to expose private work. The goal is to show that the concept is not just a diagram with good posture. First, the skill map. This shows how instructions turn into repeatable workflows. The viewer should see that skills are not random prompts. They are operating procedures that move from knowledge to action to output. Second, the life graph and domain map. This shows how work is organized by area. AI&U, AIOS infrastructure, content production, visual production, knowledge library, client delivery, and personal operations. The exact private details are not needed. The structure is the message. Third, the Google Tasks examples. These should look like real bootable task cards: title, current gate, references, next action, acceptance checks, and a void list. The viewer should immediately understand why this is better than continue this later.
Are these real outputs or synthetic examples?
For public video, the safest approach is proof-based but privacy-safe. The structure comes from real AIOS patterns. The viewer-facing content is sanitized, redacted, or reconstructed. Fourth, the MCP and database examples. Here we show routing. A request goes through a governed tool layer, reaches a task tool, domain tool, or database, and returns structured evidence. Fifth, the workbook dashboard proof. This is important because it shows the video package itself as a state manager. Current gate, artifacts, proof count, timing, and next action. Sixth, the fresh session prompt. This is the practical magic trick. A short prompt can restart the work because the package has enough structure behind it. These visuals should not feel decorative. They should feel like receipts, calm, readable, and slightly suspicious of vague claims. If you want to build your own version, start smaller than your ambition. Do not begin by designing a giant, autonomous system with 12 agents, 3 databases, and a dashboard that looks like mission control had a caffeine incident. Start with a minimum viable AIOS. Step 1. Create a project root. One folder, clear name, clear purpose. Inside it, add a manifest, a current state file, an artifact index, a decision log, and a fresh session prompt template. That is the starter kit. Step 2. Define the operating rules. What is the project? What is in scope? What is blocked? What files are authoritative? What should the agent never do without approval? What does done mean? Step 3. Define your first skills. Pick the workflows you repeat most often: research, script writing, code review, task creation, visual planning, report building, or publishing prep. Write each as a procedure with inputs, steps, outputs, and checks. Step 4. Build the work spine. Use a task manager, spreadsheet, database, or a simple markdown task file. The tool matters less than the structure. Each task should carry enough context to restart. Current gate, files to open. Next action, a void list and acceptance checks. Step 5. Add domains. Do not throw all work into one bucket labeled life, which is emotionally honest but operationally useless. Group work into meaningful domains: channel, infrastructure, clients, research, finance, learning, personal operations, or whatever fits your reality. Step 6. Connect tools carefully. Start with read-only or low-risk tools. File inspection, search, database reads, task listing, and dashboard inspection are safer than write-heavy automation. Add write actions only when the review gate is clear. Step 7. Preserve evidence. Every meaningful session should leave behind what changed, what was verified, what failed, and what should happen next. Step 8. Test portability. Open the same package in another AI environment. Can it understand the project? Can it identify the current gate? Can it continue without you narrating the entire saga? If yes, you are building an operating system. If no, you are still building a very impressive chat habit. The blueprint is generic, but your implementation should not be generic. A creator's AIOS may focus on ideas, research, scripts, assets, scenes, voiceover edits, metadata, and upload gates. An operator's AIOS may focus on meetings, tasks, emails, client follow-ups, project dashboards, decision logs, and weekly reviews. A developer's AIOS may focus on repos, branches, issues, test commands, code review, deployment gates, architecture decisions, and incident notes. A researcher's AIOS may focus on source libraries, claims, citations, summaries, hypotheses, experiment logs, and knowledge distillation. The core layers stay the same: knowledge, tasks, tools, context, evidence, and review. The details change. This is where customization matters. Your domains should match how you actually think. Your skills should match what you actually repeat. Your review gates should match the real risk of your work. If you publish publicly, privacy and rights review should be strict. If you touch client systems, approvals should be stricter. If you generate draft ideas inside a private folder, the gates can be lighter. Do not copy someone else's dashboard and then wonder why it fits like borrowed shoes. The goal is not to create the most complex system. The goal is to create the smallest structure that reliably preserves context, improves execution, and prevents expensive nonsense. Now, the failure modes. Because if we only talk about the beautiful architecture, we are basically selling a gym membership in January. Failure mode 1. Stale context. The AI uses an old plan, ignores the current gate, or works from a summary that is no longer true. Fix it by reopening live authority surfaces. Workbook, manifest, task, package, log file, or database. Failure mode 2. Unsafe tools. The agent can write, delete, publish, message, spend, or deploy without enough review. Fix it with approval gates, read-first workflows, scope permissions, and evidence requirements. A failure mode 3. Privacy leakage. Public proof assets accidentally reveal private tasks, local paths, account details, client information, or sensitive personal context. Fix it with synthetic first proofs, redaction scans, and separate production approval for real-world screenshots. Failure mode 4. Provider lock-in. The entire workflow only works inside one AI product. Fix it by storing durable context in files and systems that other environments can read. Failure mode 5. Over-automation. You automate before the process is clear. That usually creates a faster version of the problem. Fix it by documenting the workflow manually, then automating only stable parts. Failure mode 6. No evidence. The agent says work is done, but there is no artifact, no validation, no diff, no screenshot, no log, no review note. Fix it by requiring every meaningful action to leave proof. Failure mode 7. Unclear ownership. The AI starts making decisions that should belong to the human. Fix it by defining which decisions are advisory, which are executable, and which require explicit approval. The rule is simple. Automation should remove busy work, not remove judgment. A good AIOS is not a system where agents do everything. It is a system where agents can do the right things, with the right context, inside the right boundaries, while humans keep control of the decisions that matter. So here is the final takeaway. The future of useful AI work is not just better prompts. It is better operating structure. Models will keep improving. Tools will keep changing. Agent environments will keep evolving. Some will be brilliant. Some will be confusing. Some will move a button just when you finally developed muscle memory. Because apparently progress demands sacrifice, your advantage is the layer you control. Build a knowledge layer that survives the chat. Build a task spine that can restart work. Build domains that organize context. Build tools with gates. Build handoff prompts that make fresh sessions useful. Build proof systems that show what happened. Build review rules that keep humans in charge. That is a hybrid AI operating system. Not one model, not one app, not one magical command. A practical structure where different AI systems can work consistently because the context, workflow, tools, and evidence are organized outside the model. In other words, stop asking every AI session to remember your whole life story. Give it an operating system.